I have invited a few presentations to give some important updates about, the first presentation is about a modeling and observations integration workshop that happened at Ocean Sciences. It was one of those mini workshops where you got free lunch, and we ended up with over 100 people. And I had the privilege of working with NOAA program managers and NASA program managers to help bring the community together and talk about some of the challenges by scientific topic. And we want to present some of the overarching ideas and commonalities that came out of that. So Erica Ombres for the NOAA Ocean Acidification Program is here with us today to present out on this. And then I will introduce the other updates as we go. Thank you for staying. This is important community planning stuff. Thank you. Go ahead, Erica.
Thank you, Heather, for that introduction. And sorry, everyone, that I couldn't be there in person today, but logistics just didn't make it work this year. But hopefully I'll be there in person with you soon. So as Heather mentioned, we had a workshop at Ocean Sciences, and we just wanted to share out with this group how that went. So the goals of the workshop were to build more connections between the BGC observing and modeling communities, and to identify challenges and opportunities for integrating observations and models. And as you can see, there was standing room only, which was really exciting. And we heard from many of the participants, some of you who are likely in the room, that the workshop was valuable and a great part of their week at Ocean Sciences. So who was in the room? We had a good mix. We had, about a 50-50 split of modelers and observers. We had a great spread. We had a lot of students, a lot of academic and federal researchers, and then, a few other categories. And the way we structured the workshop was we had 2 30-minute discussion periods for each topic. And then at each table, a moderator took notes, and we asked our participants to volunteer to be authors for each topic. And as you can see, we touched on a lot of topics that this community has been grappling with and researching over the years, including trophic interactions, polar systems, marine carbon dioxide removal, deoxygenation, the global ocean carbon budget, episodic and extreme events, how to use machine learning in this space, the biological carbon pump, and ocean acidification. So a wide range of topics, but all focusing on connecting, observing, and modeling. And at each table, we had these framing questions that we asked the participants to discuss at their table. The questions were, what expansion beyond current observations are needed for model development? How can we increase the discoverability, synthesis, and model development through data management practices? How do we resolve the contrasting resolutions that we have between data and models to increase our understanding? And what channels exist for connections between observers and modelers? And how can we foster more conversation? More conversations like we've been having this week. That last panel, I think, was just a great observation, a great example of those connections. So here, as Heather mentioned, at each of those tables, we had groups summarize. We had 2 to 3 page summary of the discussions. And then a group of us came together to synthesize what were the commonalities, what were the common observing needs and challenges across. And here are a few that we pulled out from the workshop. And it's not going to come to a surprise to this group, but we'll just share out our findings. We need more interdisciplinary observations. We need more co-collection of the biological with the physical and the chemical observations. And we need to work on prioritizing filling those spatial and temporal gaps, whether that's due to remote geography, like high latitudes, or challenges in seasonality. In particular, I think high latitude seasonality was called out, but there's lots of other reasons why we have gaps in spatial and temporal gaps, whether that's trying to capture extreme event dynamics, not only in space, but also temporally, so we can understand what's driving those events, and also capturing what's happening in the deep ocean and in the benthos. It was also flagged that this is also will be important for MCDR, MRV. And to get to that, we need to really focus on continuing our technology development to address these gaps. So continuing to develop new sensors, new platforms, new ways to get us to these, to reduce our spatial or increase our spatial and temporal coverage and reduce those gaps. We need to think about process studies and co-develop those process studies with modelers. So I think in many of the sessions that we've been hearing about the past few days, you've heard from both observers and modelers in these different spaces, or you've heard from different groups that are maybe not necessarily groups we normally interact with, but are ones that we need to include to get our modeling more accurate. And that, I think, all of the examples that we've seen this week. Another thing we need to increase our biological rate measurements, and specifically those that can help inform the models. And so again, this is another one where we need to work with our modelers to figure out what rate measurements are informative, and what units and how to report that out in a way that models can then uptake those rate measurements. And this is where that co-development, that coordination is really going to be important. And it doesn't just go observations into models, right? We also want to use the models to help better inform our observing campaigns and our observations. So one example of this would be conducting more observing system simulation experiments, or OSSEs, in order to learn from the models, what types of observations and where are most informative, most impactful for improving our models. And then we need to continue to improve our coordination of coastal observing assets to help monitor against human impacts and threats to marine ecosystem services. And you heard the program managers on day one, we're going to have to leverage our funding increasingly as it looks like the next few years might be lean years for this research community. In the modeling needs and challenges, we need more gridded biogeochemical data products like GLODAP and SOCAT. So those of you out there who like data synthesis and like creating these types of products, talk to the observers, talk to the modelers at the meeting, and see what needs are out there, and let's get some more of these products together. We need to continue to advance the use of machine learning and statistical analysis tools to help support these data products, to make them more routinely delivered, whether it's on an annual basis or some other basis. And we need more open source frameworks to streamline the access to both the data and the model outputs, also for the software and the data analysis tools, to help make our models and these data synthesis tools more intercomparable and interoperable. And model intercomparison projects to continue to assess model performance and improve our process understanding. More opportunities to engage with observers, and not just their data, in the early stages of projects, to help co-develop that data collection and understand what the limitations are of the data. Where are the uncertainties? And more mechanisms for collaboration and capacity building between the modelers and observers. For example, whether that's observing process study design or working on data assimilation. And I just want to say that I think this meeting right now, this is one of the mechanisms that this community has for this collaboration and capacity building. So for on data management, we heard across the board, we need more standardized reporting guidelines for biogeochemical data and metadata. While in some groups, for example, like the ocean acidification group or the carbonate chemistry group, there are some standardized reporting across all the different biogeochemical topics and, sort of niche research areas. It's not always standardized how these things are reported. And there's not even standard or controlled vocabularies, which makes it really challenging for the interoperability and the machine readable part. So the more we spend on data management and data quality and QA/QC, the more usable this data will be. Along those lines, reporting out of what our QA/QC processes are and exactly, what the uncertainty are of the measurements will be really important for to include in the metadata so that can be properly calibrated into the models and used so the data can live longer. More tools to facilitate the aggregation of data in desired formats and across multiple different sources and multiple different data repositories. An example of this would be more ERDAP tools. And the use of machine readable controlled vocabularies to support that interoperability across repositories. And again, this is gonna require investment in data science expertise and semantic tools for biogeochemical observing programs. So as you're writing your grants, don't forget about the funding that's needed for the data science, and program managers in the room, don't forget to invest in data science and data management. And then lastly, enhancing the collaboration. So it was mentioned that more funding mechanisms that incentivize this co-production and collaboration on projects from the beginning to the end. So maybe requiring modelers and observers to be co-PIs along with data scientists and managers from the beginning of a project all the way to the end of a project, along with more investment in community activities like the ones that OCB supports, workshops, hackathons, small group activities like the scoping activities, and also investment in tools like glossaries that can help reduce the communication barriers that still exist between the observers, modelers, and data managers in our community. And I think, as was mentioned in the last panel, early training and capacity building in our graduate students and in our next generation scientists so that they can start their career with that functional understanding of both the observing, modeling, and the data management side will really help us advance the field. And so lastly, at the end of the workshop, we asked all of the participants to just type in one word and what value they got from the workshop. And it was really striking that, as you can see from the word cloud here, it was really seeing different perspectives, collaboration, communication, connection and viewpoints and interdisciplinary. So it was really that community connection and collaboration that really stood out to the group. And for our outcomes and next steps, we plan to finalize and publish the workshop report. So keep your eyes out for that. We're hoping to wrap that up towards the end of the summer. NOAA, NASA, and OCB program managers will all continue to work together along with you, the research community, to help address these challenges. We'll use the workshop report and the findings from it to align with our strategic planning efforts and upcoming funding opportunities to align with the research community recommendations. And one specific example of that's already currently in the works, you heard about earlier this week, is the NOAA OAR Ocean Carbon Observing Strategic Plan. And lastly, I have a little bit of homework for you guys. And Heather, I'm gonna make you hold them to this. I know that there are observers and I know that there are modelers in the room. And what I want you to do is at the next break, if you haven't yet met a new modeler or a new observer who works in your field or just in general, I really encourage you to step outside of your niche of, say it's like physiology, step outside of that niche and really use this opportunity of this workshop to get to know someone else. You never know where those chance, conversations, where those napkin doodles will take you. It could be your next big proposal. And with that, I'll end. Thank you.
Thank you, Erica. Do we have any questions about this workshop? Kyla Kelly and I and Kelsey Besson is in the room, I think. All of us were at that workshop, helped plan that workshop. So we're happy to take questions. I guess, here we go. Suzanne Craig.
Hi, Suzanne Craig, NASA Goddard. I think this is a huge need in every single discipline that I speak to that has common scientific objectives. Always say, how do we do matched in time and space, disparate measurements? What's the solution? So much so, I had a bunch of folks from an eDNA workshop I attended last week and gave a talk at, and that was the primary question that they all had. How do we leverage our knowledge with, for example, that of the PACE satellite? So that kind of convinces me that we, as a community of lots of different disciplines, that we need to be really serious about this and make it happen. Is there a vehicle beyond the fantastic workshop and report that you just gave that we should be pursuing collectively to help us fully exploit all of these amazing measurements that give us a holistic view of the Earth system?
That's an excellent question, and I'm going to let Heather take that because I think she is very.
So we had a lot of conversations across these different topics, and these are, of course, we reported on the things that were commonalities between them. And I came away from this workshop thinking we need to do this differently. We need to think about modeling and observations as tools and all become more adept at least understanding or developing a functional understanding of these. This is something I was playing around with these slides this morning, Erica and I was just like, we all are thinking of ourselves as, I'm a modeler, well, I'm an observationalist, or I'm a this, or I'm a that. And I think that's part of the problem. These are tools. They're not identities. And I guess my thinking is that we need to prepare the next generation and also build this capacity within ourselves to view it that way, that that's a tool. And I can learn how to use it too. And I can talk to modelers, or I can talk to observers, and I can, we had a number of suggestions up there about, process studies and bringing modelers into the fold before the data set gets generated. Instead of just saying, here's my data, go do something with it. Co-development of process studies and field studies, field campaigns, observing system design. There's real opportunity there to shift our mindset from identity to tool. That was really my takeaway from the whole workshop. And I think, we all kind of shared that view. I don't know if Erica has anything to add to that, but.
And I think in terms of vehicles, program managers, from my perspective, thinking about how to incentivize this co-development, it's, as a program manager, really only got one thing, right? It's how I write my notices of funding opportunity and review criteria. But I also think that, thinking about as a community, how we can prepare the next generation of researchers, how we can grow that community and also take advantage of this great networking opportunity that you guys have right now. This community, I think we've heard a lot about it over the, especially on day one. It's helped propel a number of research areas forward. And it's because of these ability to network and collaborate and be flexible. So I think take advantage of that and enjoy your networking time. It's just as valuable as listening to the talks.
So true. And I think these topical challenges, which is why we organized the workshop the way that we did, we kind of threw some spaghetti at the wall and we came away with a set of topics that people wanted to talk about. When you've got a vexing challenge, you're much more able to collaborate and see a common desired thing at the end of your collaboration. And I think it makes it easier to build that skill. But I think ocean acidification community really is a nice example for that. They had a common challenge and they brought a whole bunch of stakeholders together around a regional crisis. And that was how coastal acidification networks were born. And, you know, we can do that with other vexing problems. It doesn't just have to be that. So, all right. Well, thank you so much, Erica, for being here. I think we're going to move on to our next presenter, is it Rue? Yes. So Rue is going to give an update on the global ocean biogeochemistry array.
All right, just doing the last minute edits there to the slides there. Yeah, so I'm really happy to be here today just to share an update, and I'm really just doing this on behalf of our whole program, which is really biogeochemical Argo in the US. And this is a program that's built upon the legacy of Argo in general. I just wanted to start off like really quickly to see kind of like who in the audience is like familiar with biogeochemical Argo. Throw some hands up. Okay, we got most hands in. How many folks have used it in coursework, research, and also like a good number of hands? So it's really encouraging to see. And what we want to do is keep just encouraging and enabling that adoption of this data set. And so this is work that has been championed for a long time. Ken Johnson is the lead PI of GoBGC, as well as the SOCOM program. And so GoBGC is Global Ocean Biogeochemical Array, and this was a major investment from NSF through the Mid-Scale Research Infrastructure Program that really kick-started the biogeochemical portion of the Argo program. And so you see a bunch of folks involved with that built upon the legacy of SOCOM, which was the first regional scale demonstration of biogeochemical sensors on Argo floats. So this has really taken a whole collaborative team. So what we saw from Erica, those highlights about collaboration, and it really is deeply embedded in our program. So we're getting into the afternoon, so just in case you're getting eager to get out to your CAPE activities, the take home here is first to understand that what we're doing, biogeochemical Argo, our design goal is to sustain 1,000 biogeochemical Argo floats in the global open ocean. And for this to be successful, about half of that is kind of penciled in to be sustained by the United States, with a whole suite of other nations contributing to that array also. All the data gets integrated and unified into an openly available data system, and that's all available in near real time. And our user base for the float system is really growing. And if you look at the map here, the yellow ones are all the US floats, the blue ones are international floats, and we have, we're over 40% of the way to our kind of design criteria of 1,000 floats. But we really have now achieved the point where we can credibly say we have a global operational biogeochemical observing system. This is like a major landmark for us. However, looking ahead, GoBGC started in 2020. It wraps up end of 2025, and so we're looking for what those next steps are. And if you want GoBGC to continue to be there to enable the continued and new research that can emerge from these observations, it's really important for the community both to use that data set and on utility, and then when you have a chance, advocate for us too. All right, so just a quick step back and some of the background for those a little less familiar. So the array is a network of these profiling floats that carry chemical and biological sensors. And the goal here is really to revolutionize our understanding of ocean biogeochemical cycles, carbon uptake, acidification, deoxygenation, different ecosystem function processes. These floats all have this Argo type mission where they will spend most of their time drifting at about 1 kilometer depth. And then every 5 to 10 days, they make this vertical profile, send all the data back. And the biogeochemical part is part of the larger Argo program. So for the physical oceanographers who've joined us here, this has been established for quite a while, and we have a sustained operational array of almost 4,000 of the physical oceanography floats. This figure here is a little outdated, but we have 20-some nations contributing to that. And given that legacy, we've seen this really just transform big portions of the fields of physical oceanography. And if you look at just kind of the density of sample coverage here, you can see that, if you look at all, 100 years of ship data, we still have a lot of white space. And in the open ocean now, we have a fairly well sampled open ocean now, with a few glaring exceptions being the Arctic and really some of the ice covered zones, even though we're doing a pretty good job in the Southern Ocean. All right, so here's a couple cool animations that Andrea Fassbender provided, showing really how Argo and biogeochemical Argo is not replacing what we already do, but it fills this really important space in kind of, you think of like a Stommel diagram or kind of like what the spatial and temporal scales that we're sampling. So this is some of the observations that we have, and then if you kind of add in some of these like autonomous surface vehicles, profilers, the core and VGC and deep Argo floats, you really can start to have a much more comprehensive sampling. And so even if we've just been growing and reaching that global coverage, there's been a ton of great science that's coming out of it. So this is just kind of the smattering of some of the high-profile publications that have come out over recent years. And many of these are not by us who are like building the array and deploying floats, but is widely accessible to a whole range of floats, a whole range of scientists internationally. Here's just a few snapshots about once we get the kind of coverage that we have now, you can start to look at these really large-scale and global processes. Anything from here's picking out diel cycles and oxygen and estimating global ocean at primary productivity, more towards the SOCOM side of doing really full budgets of the relative contributions to carbon fluxes. And these are like only achievable once we have these scaled arrays. Furthermore, biogeochemical Argo has huge potential as the foundation for synthetic products that build upon the raw data. And so we saw mention earlier about the need to apply ML and AI towards getting these more gridded, regular products. As an example of recent product from Jonathan Sharp at PMEL, where we now have an Argo-based global gridded oxygen product. And yeah, so this covers even before the GoBGC period, because oxygen was kind of the first sensor that was started to be rolled out onto Argo floats. And so there's also expanding different domains of science where we think the data set can be really valuable. There's been increased interest, and we had some workshop events looking at the synergy with fisheries management as an example. Also, the emerging interest in marine carbon dioxide removal. This is really the best data set we have to get this global baseline. And so it's really essential that we do so now before any considered interventions would happen. So this is something that, if you think about also for modern reporting verification and integration with modeling and state estimates, this is kind of the combination on the observational side of what would be needed. All right, and then just to wrap up, there's just a few ways that everyone here can get involved and participate with the biogeochemical Argo program. So first off is just to use the data set, you know, develop novel applications, write papers, put in your proposals, and there's a lot of resources to help you get started with that. Some of those include, we've been hosting some community workshops. We had a great one last August as a Float Data user workshop that was kind of a hackathon format, and that was just a really fantastic event. And we had a bunch of like really enthusiastic participants, ranging from fairly experienced with data set to really coming in from a modeling perspective or other fields. And a lot of the working groups from there have really like continued on afterwards and started writing papers and things like that. And it was really a great event. There's also a whole series of OCB hosted webinars. Those are available recorded, and I think there's some future ones planned. So there's a link to check those out. And then write proposals. So NSF is very much welcoming proposals using the biogeochemical ARGO data set. You can do proposals that are purely like modeling and data analysis of the existing data set. You can supplement the observations that we already are doing with your own observations to think of different ways that can be useful for your science. Just one little note there, you know, it would kind of fit in the scope of that Dear Colleague letter, but any of these proposals or any of the core programs would be interested in receiving these proposals. And then reach out to us and give us feedback. I should go gobgc.org is the website, and there's some access points there. We're always interested to hear more from the community about what we can do to improve data access, what we can do to improve anything that we're doing to serve the community. So that's it for the summary, and have a little time for questions.
Thanks for Alessandro Taliba, University of Liverpool. I have just a comment that people might be interested to know that I'm not involved in it, but there's actually a newly formed SCORE working group called 4D BGC, which is chaired by John Sharp and Raphael Sozede in Villefranche, which is really aimed around how can we go about exploiting these new four-dimensional data sets that we're able to generate here. So, you know, for folks in the room, that might be of interest to just get on the radar and engage in their activities as they unfold.
Yeah, thanks for sharing that. That's great. Yeah.
Hi, I'm Karen Stamiashkin, Bigelow Laboratory. I was just curious, you highlighted that the data is available in near real time, and I'm wondering, as far as people trying to use it, what's the kind of quality assurance that you need to go through to use data in near real time?
Yeah, so there's quality, there's a whole set of quality flags, and I could point you to, there's some kind of more detailed documentation about kind of what to expect with each quality flag, and it varies by variable also, but generally I wouldn't use real-time data for your science papers. Wait for the delayed mode that gets adjusted, but it can be a good source depending on, you know, we do have like real-time adjusted data that gets kind of an automated correction that can be very useful if you're doing like thinking about doing data assimilation or something like that. But if you don't need it like from yesterday, you want to wait a bit for the quality control to improve the data set. There's also kind of like quarterly snapshots that have like a DOI that's a good version if you want like a version that's reproducible and citable for your paper. So it depends on kind of the use case. Yeah.
Anna Miller, University of Rhode Island. Hi, Ru. I saw a few BTC argos in the Rossi and maybe in the wet LC too. I'm wondering how do those, are those okay down there? Like it's very shallow. It's not like uniformly greater than 1,000 meters, and there's ice for most of the year. How are those okay? Like, are there going to be more of those? Because a lot of
it's a risky type thing to put them, particularly where it's very shallow. Sometimes there's cool features, and we kind of like put them in there. Sometimes they do fine. Sometimes they'll like end up like they could sit on the bottom and then come up and be fine. But there is some risk that they like get stuck down there or lost. So you'd expect a higher loss rate down there, but sometimes they're fine.
But they return good data in these most of the time. Is there?
Yeah, they don't get stuck on the bottom. Yeah.
To put more down there?
What's that?
Are there plans to put more down there? Or is that kind of up to individual PIs to put them down there?
Oh, the ones down there. So I'm not part of the SOCOM project. I'm a little less familiar about their deployment plan. If you go to at least for our GoBGC floats, it's also going to be interesting. If you go to the website, we have a map of like upcoming deployments to get a little preview of how we're trying to, fill some of the holes that we have.
Thank you.
A couple more in the back if there's.
Oh, we do. Oh.
I had a question about the spectrophotometer that I guess is used for getting nitrate.
Yep.
What's sort of the latest on that? Is it, how reliable are the nitrate numbers when there are other chromophores in the water? Is there other information that you can get out of those spectral data besides nitrate, that kind of thing?
Let's see. So I'm not super sure about like a lot of the CDOM is going to have those same UV absorption, and I'm not quite sure about the level of interference there. Then in terms of getting more products out of it, so one product that Bari folks are working on is actually getting nitrite out of it. But there are, for many of the floats, if you want to dig deep into the raw data set, it's not in kind of the polished version. You can get to the full spectra, and you could start to explore what else you could get out of there.
All right. Thank you so much, Rue, for giving us that update. And all of you be thinking about these data sets and how valuable they are. So OCB has been pretty active in the marine carbon dioxide removal space in terms of trying to build the academic communities around.
Gliders.
What's that?
I still have my microphone.
Oh, so sorry.
I'm
talking out loud. So we had a big multi-stakeholder workshop in 2022, and one of the outcomes of that was the establishment of regional nodes to bring together regional interest around marine carbon dioxide removal, which really this is for the North American coast, is different in every region, as you're going to hear from Jessica Cross, who was our fearless leader, she and Jamie Palter. So Jessica is just going to update you on some of those regional node activities.
Hi, everybody. Oh, we're doing okay, I think. Thanks for the opportunity to give you all an update about the working group that we had. If you recall, as Heather said, about 2 years ago, we had a workshop on marine carbon dioxide removal just as this issue is kind of hitting our community, which really proved valuable and entrained a lot of you in the conversation in a way that's been very helpful. Since then, the steering committee has sort of agreed to support us to make this not just a workshop, but a working group going forward. But the problem that we had is that the field moves so fast that every time we decided to do something, we would find out that someone else was already doing it. So in the end, what we decided to do with the working group was, rather than focus on a specific issue or aspect of MCDR, was instead to focus on this place-based idea, which I'm going to throw up here. Essentially, even though most carbon dioxide removal at this point is theoretical, it's something that we're experimenting with in the lab. We're trying to get some demonstrations going in a couple of different places to prove its viability, its efficacy, its safety. Ultimately, all MCDR is going to happen in a place. right? A place with a unique culture, a place with a unique environment, a place with a unique economy. And probably at the very beginning, it's going to be happening at small scales, which means we need to be focusing on place at small scales. So the OCB working group has spun up to include regional nodes, kind of similar to the coastal acidification networks that we heard about earlier, adopting a similar geography of thinking through the large marine ecosystems in the United States. And so we polled all of you to say, hey, who wants to help? And more than that, who wants to lead? And these were the lucky people who signed up to sort of help us chair these regional nodes. So you see down at the bottom, Pat, Jamie, and myself are kind of in charge of coordinating the regional nodes together and trying to make sure that they adopt lessons learned from each other. I send a lot of emails, and I'm sorry about that. But the regional nodes themselves are chaired by the folks that you see on the screen here. So in the Northeast, that's Adam Subash. In the Southeast, it's Adrian Horfrost. The Gulf Coast is George. The West Coast is Christina Frieder. The Northwest is Meg Chadsey, and I am begging for someone to step up and lead a Hawaii and Pacific Islands regional node. There have been multiple groups down there, local stakeholder groups that have reached out to us saying that they are interested and want to be involved. We just need a scientist to help us step up. So if you are in any way, shape, or form connected to that community and you are local and this is something that you want to take on, please, I promise we have like an engaged stakeholder base that wants to work with you. So far, we've really encouraged folks to try and have in-person meetings as much as possible, and 2 of our nodes have done that so far. So many of you may have attended the Gulf of Mexico regional node, or at least heard about it, because it happened at Ocean Sciences this year. So huge round of applause to George for and his team for getting this off, getting lift off with this, our first regional node meeting. They had about 20 participants. And really they decided to focus on next steps, include focusing on the Mississippi River Basin, as well as starting to get involved in policy and legislation. So that was kind of a really cool outcome that grew out, again, of the people that attended that node, sort of the connections that they had and what they wanted to focus on going forward. So again, sort of connecting scientists to decision makers and actionable outcomes in that way is something that we really wanted to do when it came to these regional nodes. So we're really proud of that outcome. We also had in the Pacific Northwest a regional node meeting that was led by Meg Chadsey, as well as support from some of our colleagues in British Columbia, so that we could pull together everywhere from Oregon all the way up to Alaska. And that was attended, really well attended. We had more than 65 participants in a bunch of breakout rooms. And what's really building out of that is this idea that people value this regional perspective, but would really like to break it down more. Again, a lot of these projects are going to happen at the really small scale at the beginning. And so focusing again on that really small scale is something that at least is coming out of this region. That's not to say that the other nodes have not made an effort so far. They certainly have. You may find updates from your node here. So certainly the Northeast, the Southeast, the California Current, and again, my plea for anyone in the Hawaii Pacific Islands region who might be interested in helping us out, I really encourage you to do that. So in particular, one of these folks I think has held a virtual meeting so far. Yes, the Southeast has held a virtual meeting. I know the California Current node is partnering with a couple of local nonprofit organizations to try and get their node meeting off the ground. And then the Northeast, I think, is already tentatively planned their workshop. So save the dates for the second week of September if that's your particular region and you're interested in participating with them. The second thing that I've been asked to update all of you on is that our sister organization, SOLAS, a Surface Ocean Lower Atmosphere Study that is international in scope, is also focusing, has an MCDR working group, and that is chaired by Lynn Hoffman and Leonard Bach, who you see pictured on the screen here. And Lynn and Leonard have put together a activity that's designed to build consensus around what is sufficient marine monitoring, reporting, and verification strategies, but also feasible. So those two things sort of bring together. You know, what is sufficient, necessary, but also possible to do in the real world. It can be really hard to measure and model for marine carbon dioxide removal. And so Leonard and Lynn have focused on asking a core group of 7 questions to what they're calling continental nodes. And so for North America, the chairs are myself for the US, Cohen Bauer for Canada, and Jose Martin Hernandez Leon for Mexico. And we're working pretty closely with the North American Hub to try and answer questions for all of you. So you see this QR code on the screen right here. Martine, Cohen, and I wrote up a draft response to these 7 questions that you can find at this QR code right here. And maybe you all would be interested in providing feedback, because I'll tell you right now that Cohen, Martine, and I do not believe that only 3 people should represent this entire vibrant continent that we live on. We would really, really like maybe your feedback. I would like to see some more phones in the air. Take pictures of my QR code and leave me feedback, please. Please? Please help me. Thank you so much. We are requesting feedback by June 24th. It's really easy. We put it in a form. You can either review it like a journal article if that's something that you want to do, or you can enter specific feedback on specific sections of the report in this Google form. I think that's it for me. I had updated the slides, so if those get emailed around to you, you may find a handful of more links and QR codes in them as well. You're welcome to reach out and sort of see new guidance from the EPA on MCDR, and then 2 events of interest for regional nodes here in the Northeast. That includes a workshop that's happening in the Pacific Northwest about linking marine carbon dioxide removal to marine energy, and then as well an EPA listening session on the Loch Ness project that's actually being led right out of here in Hui, which I believe is on Monday afternoon. So if Heather and May send those out, you'll be able to find those links more directly, or you can just Google it. It should be pretty easy to find, because the EPA put out a press release for both of those items that I just talked to you about. Questions about the status of OCB and SOLAS MCDR activities?
I'm going to throw it up there. It might be a little weird.
Yeah, Jim Moffitt, US City. I was just wondering, in these groups, how, or it's largely the academic community, but how is the, you know, the emergence of investors, non-disclosure agreements, patents, that kind of thing, influencing the way that you all interact with each other?
I think you would have to ask that question dependent on node itself. Go ahead and just skip to the last slide, May. Keep going. There you go. That's all the links, all the people and all the links on one slide. I think it would depend on which project and which node in particular you're talking about. I will say that there is energy on both the private, the nonprofit, the government, and the academic side to try and work together and be as transparent as possible about this, because that helps build the social license to operate. So right now, you know, there may be some tension about how quickly data gets published. Academics really want good, strong academic rigor. Private companies want to be sure that they know what they're talking about before they put things out on the street, just like we do, sort of from a slightly different perspective. And communities want to see everything immediately. And so there's trying to balance, again, the time scale of publication is something that I've heard about, but overall, nobody's trying to operate in stealth mode insofar as I've heard. Other questions about regional nodes? If you'd like to get involved with your regional node, please see your node representative. Any of the other links that you can find here on the screen?
I will link these in the agenda too. I'm also going to link the agency presentations, because I think a lot of people would like to have access to those.
All right, there's so much more going on with marine carbon dioxide removal than what we've just talked about here. I did try to keep it focused specific on OCB and SOLAS activities. Of course, if you want to know or chat about anything MCDR, you know I'm happy to geek out with you any time of the day. Work weird hours sometimes. Product of obsession. Thanks. everybody.
Thank you, Jessica. Last but not least, where's my agenda? Right above your button on here. So we're going to have a brief update. We had this great session yesterday about nutrients and red fields, and we talked a lot about iron, and turns out we have a really nice update on EXOS, Exploring Ocean Iron Solutions, and that's going to be given by Jessica Drysdale, who is also joined online by Paul Morris. So we will have Jessica take it away.
Can you hear me? Yeah. So, hi everyone, my name is Jessica Drysdale and I work here at the Woods Hole Oceanographic Institution on the EXOIS project, or Exploring Ocean Iron Solutions. And as was mentioned, Paul Morris, who's the main project manager, couldn't be here, so is available online. So this group started in late 2021, has been running for since then. We have about 65 members at the moment from 36 different institutions around the world. We hold meetings generally the third Monday of every month. If anyone cares to join, you can send me an email. It's at the end. And I will give you, the topic is David Siegel talking about carbon durability. So why do this? This chart shows the trajectory of carbon dioxide emissions if we continue with business as usual to emit at current intensities. And so to stop this from happening, the largest effect is going to come from reducing emissions, but that's not going to do everything. We do need to also remove legacy carbon dioxide from the atmosphere. And to do this, we need CDR methods. So why use the ocean? The ocean plays an outsized role in the carbon cycle. You can see the size of these different circles represents the amount of carbon that can be stored in the different parts. So the ocean has 50 times more carbon storage capacity than the atmosphere, and 15 to 20 times more than the land and plants. So overall, this means that the deep ocean is the single largest, most accessible carbon reservoir on meaningful timescales for climate change that's occurring, and so should be considered as an option for storing carbon. So why is ocean iron such a promising solution? First is the idea of scaling. So previous work has estimated that from 1 to 4 gigatons of carbon dioxide could be stored per year. A little iron goes a long way. Nature is pretty efficient at using iron. Previous experiments haven't shown quite as much of that efficiency, and so that would have to be the focus of a new experiment. Cost. Iron fertilization is relatively cheap. It has a lower cost than other MCDR methods, and iron is already mined fairly cheaply, and energy from the sun is obviously free. And lastly, experience. We've had 13 previous experiences with no directly observed harm to the ocean, but that's another question that will have to be observed over longer periods with future experiments. One experiment in particular, SOFEX, showed the removal of 4,000 tons of carbon dioxide in about 1 month. So what has EXOIS done? So far, right at the very beginning, the whole idea was to create a set of guiding principles to essentially, with the idea of preventing bad behavior, rogue engineers, and false promises, and really to just do good science and with due diligence and have public involvement. So these 5 principles were published in Nature Correspondence in 2022 as pretty much the first sort of group activity. Since then, as I mentioned, we've been having these monthly meetings and with various presenters. Some of you here have presented, some of you are members in the group. some of you just come in and watch, and that's fantastic. So we had a first meeting last May at Moss Landing Marine Laboratories, and this was the product of that, Path Forward. It is available online. You can also get out your phone, download our document, but it was really to plan on moving forward on determining the best ways to understand carbon capture, durability, scaling, and ecological impacts, as well as the ethical standards, costs, should this work forward. Since then, we had a meeting only 2 weeks ago here in Woods Hole to really hash out a field plan for developing a structure of what a first field deployment would look like, and develop a roadmap for work and launching this under various different funding options, depending on what happened and how much money we could get. A social sciences and governance meeting is coming up in 2 weeks. So what came out of that recent meeting was pretty much a choice on location. The Northeast Pacific has been chosen due to the ability to use Ocean Station PAPA for baseline data and the extensive study of export that has occurred already in that region. There's also a region of generally low kinetic energy, hopefully making it easier to both track a bloom and also lay out a coherent patch of iron. It's also relatively accessible. So lastly, a new generation of ocean iron fertilization. Why go back and try this again after 20 years? What's different about this experiment? The first is that we've really come a really long way in this time with autonomous technologies, and it allows for much longer and more strategic monitoring of both patch growth and dispersion. Whereas previous experiments have mostly ended within about 30 days, we would expect and hope that this one would go for over 60 days with potential follow-ups after that. We also are trying to create a more inclusive stakeholder environment. We have an enhanced understanding of carbon sequestration, and there's still challenges ahead. Obviously, how to effectively use technologies that we have, permitting under the London Protocol or London Convention, improving the models that we use to know when and where to go, and obviously need money. So that's about all I have for today. I'd like to thank our sponsors, the Astera Institute and Woods Hole Oceanographic Institution, and as well as the McConnell Family Foundation, and then the Biological Oceanography Lab at Moss Landing Marine Labs helped fund parts of that meeting. You can visit us at oceaniron.org to find out a lot more. All of the old presentations that have been given are there for you to look at or comment on if you want. You can email me to get on the list to watch our forums. If anyone cares to give us talk sometime, you can also email us, and gladly love to hear from people in this community. I think that's about it. Yeah.
Does anyone have any quick questions for Jessica?
Go enjoy the sunlight.
Got one question over here.
Hey, thanks for a great talk.
Hi.
The question I want to ask is about the affordability of it. One of the previous talks yesterday showed that iron sometimes needs other trace metals to produce the bloom. So all I'm thinking is, if you need other trace metals, is it still going to be affordable?
I think that depends where you decide to go, but there is also talk as part of the experimental procedures have also been discussed doing using clays and things that also contain other elements. Paul might have a better answer to that question. Did you hear the question, Paul?
Yeah, hi, thank you for allowing me to call in remotely. I'm in DC. Yeah, I think we'll start with iron as our initial thing that we will add, but one of the paths forward will be what we call the bake-off, which will look at other, say, other elements that might be added along with iron to maybe improve that carbon export and efficiency. So really, we're going to start from where previous ocean iron fertilization experiments finished off and then go from there.
Thank you.
Anyone else?
Hi, Corday Sheldon, Rutgers. So speaking of other ocean fertilization experiments that have been conducted, you mentioned that one, resulted in carbon, enhanced carbon removal, but there have been many of these experiments, and I believe more than just one of them looked at enhanced carbon removal. Can you speak a little bit to sort of what data we have now on the potential for this to be effective?
So all of the experiments did form blooms, but the results of how much carbon was able to sink out and actually be durably stored was kind of an unanswered question for a lot of those experiments because they weren't monitored for long enough or we didn't have the equipment to do that, from what I understand. There's probably people here who can speak better to that than I can, including Paul. But that's my understanding, and that's part of why the experiment is hoping to be continued with better, using a lot of that knowledge of what was missed to be able to get at that answer. So, Paul?
Yeah, I think, Jess, you gave exactly the right answer there. The previous experiments weren't primarily looking at what the durability was of the carbon storage. So really, that's a question. That's an open question. We really need to go back and answer that with these new experiments using the better traces that we have at our disposal, the better methods. And yeah, that's what we hope to do.
Julie Granger, Yukon. So is this an experiment or is it an attempt to actually sequester carbon, because there are no preformed nutrients in the subarctic Pacific, so it wouldn't actually in net sequester anything?
No, that's exactly right. It's an experiment.
Yeah,
Han Ji-Wang from.
Oh, sorry.
Oh,
yeah,
Han Ji-Wang from.
Yeah,
Go
go ahead.
Okay, I'm going. Okay. Sorry, my question was Oh, I got back. So the question was, do you plan to measure other greenhouse gas, for example, the methane or N2O during this trip?
There's been a lot of talk of dimethyl sulfide measurements, but obviously I don't know about other gases exactly were determined. Paul?
Yeah, as part of our workshop a couple of weeks ago, we talked about what other gases should be measured, included dimethyl sulfide, methane, and others. We're going to be reporting back to the community from that workshop at our July forum. So if you want to come along and listen to that, we'll give you a full readout from that workshop.
All right, I want to thank Jessica and Paul for being here and for sharing the update on the field planning workshop. With that, I want to free you all to go explore Cape Cod for a couple hours. Dinner doesn't start till 6:30. If you come tomorrow and you're leaving right from here, you can bring your luggage and store it here, and that would be okay. I also added a link to the agenda, and it's also in the participant documents folder I shared this morning. There's a little link of fun things to do, and it includes a few trails you can walk locally, so feel free to go have fun, and we'll see you tonight.